Hey, welcome everybody. This is Richard from Repair Room USA, and today this is day 2 of the iPad Rehab course. They actually covered heat shield and we reballed a bigger chip, which was a baseband CPU. We actually took it off and then we reballed it, put it back on, kind of like we did it yesterday. One of the students in class, I'm not going to say his name, but it starts with a T. He actually broke his chip in half. The reason he did is because some of these chips, if you look at them, they look square, but in reality, they are actually rectangle. So when you put them in a certain kind of stencils, if the stencil is designed to go a certain way, you have to be mindful of that and just be careful, because some of these stencils, if you put pressure on it, thinking that it's in right, and you put pressure, then it's going to snap. And I think the way he did it and what he mentioned is that when he was taking the little nubs off, that he was a little bit too rough and he was more scraping it instead of just using the iron to pull the nubs off. So that's what you're kind of doing. You're keeping that iron really dry, and you're going and you're basically kind of just tapping these little nubs off, and you're trying to touch the board as little as possible. So today what we're going over is heat shields. Heat shields are these RF shields that protect certain parts of the board. There's a few methods on how to do this. Okay. The old answer was, there's actually a tattoo about this. It was high max heat and max air. So that was the way. It was just brute force the heat shields off, and then that's how we would do it. We are going to do that. The great thing about this class is that we all learn together. Our mistakes is a teaching opportunity. Now, the old method is good, but it's good for older iPhones. And some of the older iPhones, like the 6, 6S, stuff like that, before that, the alloy that was used to attach the shields was not as strong. So what we're trying to do when we're going in there and we're taking one of these shields off is that we're trying to do it in a way that we can get it off as quickly as possible, but without damaging some of the components that are underneath these shields. So that's one of the things that we have to be very careful, is how we take these off to not damage things that are actually located just underneath these shields. Now, sometimes when you're taking these off, you have to be careful because there will be small connectors like this, and those connectors will melt. Some of these are actually pretty good, as long as you don't go over 450, that you're not really going to damage them. The best thing to do is just when you're going around, to just know that they're there and try to either avoid them as much as possible or not go over 450 if you have to. Usually around 430 and under, these connectors will be okay. So just be mindful of anything around there that might melt. A lot of these connectors are fine until you actually pull them off the PCB. That's when immediately they will melt. So if they're on the actual board, the heat will dissipate and they won't melt. As soon as they get pulled off, though, they will melt very easily. One other thing that you have to know is iPhone 7s and 8s will have glue, and there's stickers. And so if you don't look for the glue or anything that's around, you have to look very closely at anything that's around these heat shields, and make sure that when you're going to pull it off, there's not a sticker on there that's going to hold it on while you're trying to get it off. So you always want to make sure that you look and make sure there's no stickers, nothing that's going to get in your way of getting this off. Look for any components that are around there, and just be mindful if there's components there that they are going to get damaged if you use too much heat. If you look closely, some of these connectors will just snap off. If you look closely on some of these, you'll see that they have these little holes. And if you want, you could probably go around there. Let me see if I can get this in focus a little bit more. Okay, so if you look around there, like some of these will just snap off. Like they have the little things where like they will come off very easily. So you don't have to remove some of these. You can just pry off and get these little snaps off, and you can actually remove and make it a lot easier just to do it that way and just break these off. Now, when you're doing this, don't use your favorite tweezers because you're going to bend them all to hell. That's why if you do bend them, and which you will, having one of these bad boys right here, that will actually help you straighten these tips when they get bent. These right here, they don't bend very easily. I got these. These are the 3SA CHP is on these. I don't remember where I got these from, but I still have not bent the tips on these. So these are pretty good tips. With a lot of these blue guys right here, I love these, but the tips will get bent very easily. So you're always having to straighten these back out. So the first method is brute force. High heat, max temperature, max air, and you want to make sure that you have the biggest nozzle that you can actually fit on there that's possible. I would highly recommend, if you can, just use no nozzle. So max air, max heat, and you want to be able to grab what you're taking off. So like, for example, I'm taking this one off right here. I want to be able to grab it by somewhere. If I just try to grab it by the actual shield right here, then it could just slip off. But you see these little holes? If I can just grab it by one of these little holes right here like this. And what we want to use when we're using high heat, max temperature, is that we want to try to hold it in a way that we use gravity to do the rest. So we get a good grip of it, we bring in max heat, max temperature, and we just blast it off. Let's try to do that right now. So let me get my thing. Let me take this off. I don't know how much I can get in, and yeah, I'm going to try to get as much in as I can. It's hard since I don't have that much space right here, but I actually have a lot. So let's turn this all the way. Mine goes up to 480, 99. Okay, that's the max mine does. All right. So let's go in here. Now, you got to be mindful of your fingers. You want to keep your fingers away. Let's see how long this takes. Boom. Now you see that. Now I didn't damage anything under there. I was able to remove everything. And while I was trying to hold it, I was pretty much in an empty spot. So you see this alloy that's around here? This is the alloy that's actually holding these plates on. So by using max heat and max air, I was able to melt this alloy and get it off of there without actually ruining anything under here. Now, the telltale signs when you're looking in here and that you actually ruin this PCB is you'll see little Mickey Mouse ears popping out of your chips. See that? That's one right there. See these? Those are little Mickey Mouse ears. That is what you're trying to avoid. But sometimes it's very, very difficult to avoid. So one of the lessons that when you're taking off heat shields that you need to know is we're only removing heat shields when it's 100% necessary. That's it. If the repair calls for removing the actual heat shield, then we will do it. If it doesn't, then we won't worry about it. So it looks pretty good. I don't see too many Mickey Mouse ears. This is a chip right there. Now, how can we tell if a chip has underfill? Some chips have underfill. And underfill is this glue and this paste that they put on chips. A lot of the iPhones will contain chips that have underfill. Let's look at this other PCB. And let's see. Now, for example, this chip right here. Does this chip have underfill? If you can see traces going in and around the chip, you see those tiny little traces? Let me see if I can get in a little bit better. That's as far as I can get in. So if you see traces going into the chip, that means that chip has no underfill. Let's see, let's look for other chips. This chip right here. You see this chip all the way around? Now this chip, I think that is the NAND right there. So that chip right there, if you look around it, it has underfill. Especially on this side. I can see, or I can't see the traces. But if I look on this side, let me see here. Yeah, it does have some kind of underfill. So stuff like that, when you're removing chips, and this is just a little thing I'm talking about, when you're removing chips like that, you have to cut around all this to be able to get that chip off safely. Because if you don't, when you try to take it off, you're going to pull all these components off of there. And you see this right here? Remember when I was telling you to try to get these serrated, these tips right here with the serrated edge on them? That is what that is good for. To take stuff like this edge right there off. And then for cutting around the components, I will have another video, and that's an advanced technique, but I'm going to show you the easy way of doing it, and it's actually pretty cool. Now, one of the examples that they used in the class was with a lot of the Samsung boards, and they actually broke out a flip phone motherboard. Now, I don't have one here, but there's another method, and this also works with later models in the iPhones, not the earlier. The earlier, we were going to do max out, max heat, max air, but in the later models, there has been another method that has been developed, which is a pry and pray method. Now, let's see if we can do actually pry and pray here with one of ours. Now, in order to do pry and pray, you're going to want to get a tool that has this. So if you look at this, this is a very strong type of metal that I can use to see how it's already messed up. So you don't want to use new ones for this. You save the new ones for actually scraping and reball, stuff like that. But here, since it's already damaged, this can be used for pry and pray. Now on pry and pray, what you're doing is you're looking at a lid and you're actually using the corner to make an indentation like that. So I'm using this corner to make an indentation. And where I can make the indentation, alright, and you would have to go all the way around the board. And you want to go into the steel. You don't want to go in too deep. See how I just went in deep? Because doing this, there's things that are located underneath this lid. And what I could be doing, and I just snapped off my my tool there. What I could be doing is I could be damaging some components that could be located under there. So that's what I'm doing. I'm going around and I'm doing pry and pray. But first, I need right there. Let's see if I can go around this a little bit more. I don't want to go in too deep. I'm just trying to get the very, very corner of my tool in there. All right, and then basically the gist is you would try to go as far around as you can. And then you have to get a tool that's strong enough to be able to get in here and break this open. So let's see if I can use these pliers here. I don't think these pliers are going to work. I don't want to bend up any of my tools, especially so I don't have, let's see here. I need something else. Here they are. the old snips. These right here, with these, I might be able to get this up just a little bit. Get in here. All right, there you go. It starts lifting up. And basically I am just using this like a sardine can. And hopefully I picked a side. Now this is what you're trying to avoid. When you're bending these up, you're trying to avoid canning. And that is when these actual lids start folding up on itself, and it's going to be pushing in on a part. So because it's going to be folding in, it's going to be pushing on a part. So I'm going around this, and I'm trying to be very careful. And this is see how it's going in right there? That's what you're trying to avoid. So I need to actually get over here and say, no, no, no. I don't want you to do that. So I'm trying to get you off here. There we go. So you don't damage anything that's vital under there. So basically I am peeling this off kind of like a sardine can, and I am going all the way around. There you go. And I am peeling this off little by little. And remember, we're only doing this if we have to get in here. If there's a component in here that's 100% necessary that we have to remove. Alright. So basically I'm going in here and I'm just rolling this up like a sardine can. Rolling it up. Getting in here. Luckily there's no components under there that are vital. And sometimes this is how you have to get in there. Alright. Because what you don't want it to do is you don't want it to, those tips to fold in on each other. And I don't want to ruin other parts that are necessary. So there you go. I'm rolling it up. I'm trying to be mindful that it's not going to can and the edges are going to go in. There you go. All right. Now, let's see what I ruined. Let's see what I damaged in here. Oh, it was a big shield. Luckily, around the shield, there's a lot of space. A lot of space. Now, what's good about this method? What's good about this method is we're not using heat. Now, see this component right here? That one got taken off the board. All right. So sometimes just because a component got removed doesn't mean that I have to put it back. Well, this one I think is important. Usually with anything that's got this little dot on it, so now I'm going to have to make sure that this component is not damaged, which looks like he's okay. So see that right here? He has his little end ripped off. Now, if that end is ripped off, and I just lost him, where'd he go? If that end is ripped off, that means it's right here. This is that little end that got ripped off. So that component is ruined. So in a situation like this, what can you do? Well, the only thing you can do is pray that that component is not necessary for something to run. If it was something like a capacitor, is it vital? Probably not. If it's a resistor, is it important? Probably so. If it's a coil, is it important? Most likely. So in this situation, what is the only thing I could do? Well, the only thing I can do is if I have another board like this, a donor board, that I can go exactly like this one, that I can go back and be very mindful when I'm removing this, not to get anywhere close to this component right here, and knock him off. Or even if I do, just try to make sure that he's whole when he comes off. I would have to actually take another one from another board and put it on there. Or I could go into ZXW. I can go and look. This is a Motorola 5G. So we go into Motorola, and Motorola, there is not a lot of information on here. Let's see. G5, 3, 5G. This one might be similar. And you have to decide whether that board is the same as that board. Does it look like it has the same configuration? So where would that be? Now that looks like, if I have this correct, it doesn't look like the same board at all. So this would be, I don't see it. Okay, it's got these 3 connectors here. So those are the same. Then it's got capacitors here. Those don't look like they're here. So it looks like I'm missing the capacitors that are supposed to be going here. And then it's got a little nub sticking up here. On the bottom, it does not look like the same board. So let's look at the connector side. The connector side, it's got these 2 big connectors right here. If you look on our board, all right, the connectors are 2 big connectors like this. And on ZXW, just one right here. So this is not the same board. It's almost similar. Now it might be able to give us an idea on the board layout, but some of these share very similar board layouts. But if I look at some of these here, I can't tell. So it's not the same board. So a lot of times you won't be able to find that. That's one of the things that I'm saying, is there won't be any schematics or anything on certain boards that you find. So that's why you need to have multiple working boards, or for parts, where you can swap a part out and put it on the other one. So what would you do? That's the only thing you can do. All right, and let's say I have another part. What do I do then? Well, don't bend the PCB, especially with some of these. Pretend they're like chewing gum, okay? You can actually flex these, but when you flex them, you're actually breaking tiny little traces that run through these boards. So you need to make sure that when you're praying and you're pulling these things off, that these are stable and they're not flexing and bending like chewing gum, because you're going to break other things inside that you're not going to be able to see or fix. So that's another downside to pry and pray. Now you can only do that when the heat shields are soft enough, kind of like that one, which was almost like, it was softer than peeling a sardine can. It was pretty soft. So right now what we're doing is we're fixing problems that we made for ourselves. All right. So I want to make puffy little pillows. I go in here. All right. I am sort of happy with that. But before we worry about these puffy little pillows, and they're going to form themselves either. First, we're going to remove this component. I'm going to get some of my tweezers here. And you want to get comfortable. You want to move the board in a way that you can easily remove this without knocking other things off. So this is going to be the best spot. There's nothing here for me to knock off. I'm going to grab it and I'm going to take it off. So I'm going to get my heat. I'm going to set it to 60 air, and let's try 385. Let's see how long it takes me to remove this component. Grab it here. I'm going to bring in my hot air. Yeah, you see how hard that was to do? And that was at 385. Now, did I lose my component? I did. Where did he go? These guys are so small that I don't see him. Once you lose them like that, they're so tiny that they're pretty much lost causes. So, okay, that teaches us a little lesson. When we're doing stuff like this, we need to be very careful not to drop them. So let's do it again. Now, if you look at this real quick, this is a great teaching opportunity. Once you remove them, don't let them go. All right? Now, you see the difference between this? That's a puffy pillow. That is another ground plane. So you can see that most likely this was grounded here. So it was most likely a capacitor is what we're pulling off here. So these capacitors, if it's a capacitor, it's probably not a big deal. But I just want to show you how do we remove components and put them back. So let's start again. All right, let's set them down right there. Now we don't lose them. All right. So now we need to put this guy somewhere where we won't lose him. All right, and now we need to prepare this right here and get it ready. Okay, this for example came from our donor board, and that if we wanted to replace this, we could. So we noticed that these require a lot of heat. So I need a lot of heat. So let's get my iron. I'm actually going to use my other iron. I'm going to use my iron where I have a lot more thermal mass, and I'm actually going to turn it up to 380. I'm going to go in here, put flux is your friend. Okay, got plenty of flux on there. Now I got to make sure my iron is nice and clean, because if it's not clean, then the point of this is that you want solder to stick on the end. So that way, when you're putting it down, that it's going to go where you want it to go. Okay, that's one puffy little pillow. Way too much. Alright. Now I need to remove this blob right there. The easiest way to remove him, to get some of my wick, clean off my tip of my iron. Get some of this. Bam. Alright. I got my puffy pillows. And now I need to get ready to put this component. Now, if I try to get this component like this, and I'm going to put them here, what am I going to run into? Well, I'm not going to be able to grab them very well. So what you want to do is you want to turn this and make it comfortable for you. And always be mindful, where is my air going to be going? My air is going to be going from left to right, because that way I'm blowing on the least possible number of components and getting them hot. So let's get this guy ready here. and he's going to be going right there. So there's a couple methods that you can use. You can kind of position him where he needs to be going. And he's stuck on my tweezers right now. There you go. I can kind of put him where he's supposed to go. Right here. And with just... I need 2 tweezers. Hold on. I don't want those. Where's the other ones? There they are. Alright. Put them right there. Now we're going to try a couple methods. We're going to try going in from the side slowly and just seeing if you can get them stuck on. So I'm going to keep my temperature high at 380. I'm going to leave my air strength at 60 and see if I can come in here slowly without blowing them off. The only other method is to actually hold them while you're bringing the heat. And see how he's stuck on there now? He's stuck on there. He's not going anywhere. I probably have way too much airspeed. Alright, he's stuck on there. He's not going anywhere. You see that? So, once they're on there, they're not going anywhere. Because of thermoelasticity. Once they're stuck on their little pads, they're not moving out of there. They're stuck. So it's even once something is on there, it's very hard to blow it off unless you bump it off. Once you bump it off, yeah, they will blow. But once they're on their pads, they're not going anywhere. So that is the second method, pry and pray. The third method, which I don't recommend, and I'm not even going to call it a third method, is you're going to get a rotary tool. They sell these little tools in China, these little rotary tools, which you can put different attachments on the end, and they have an attachment which is basically a little blade, and you're going to go and get these little guys, and you're going to put the right attachment, and you're going to cut all the way around one of these plates. The problem when you do that is when you're cut around something like that is that you're going to get shards everywhere. And from my experience, I've seen PCBs that come where components are actually etched into and their data is ruined because if you slip just a little bit too far, and when you're cutting that lid around, that heat shield, if you slip and go a little bit too deep, some of these CPUs are located very, very close to the actual very top of the lid. It's not a good idea to go in here and start cutting if you're going to be scratching or damaging components that are underneath these heat shields. For this board right here, we've noticed that a lot of these alloys that they use to put these on are actually not that hot. They don't have to get that hot to get them off, so they come off pretty easily. So on a board like this, you're going to be using the max temperature and the max heat. With other later motherboards, the pry and pray is the option, but you got to be careful with canning on the sides. When you're pulling stuff off, you got to watch the corners because they're going to dig under and they're going to dig up chips and move things around. The drill method, the actually trying to cut it off, it's highly not recommended. You're going to get little metal filings everywhere, and when you have metal filings and tiny little components like this, you're going to have a ton of problems. So it's not recommended. So what's the other way? No, the last way is when you have an alloy and you're trying to degrade it and make it into another alloy. What's the way of doing that? It's actually using a lower temperature solder, like bismuth, like we talked about, 148, and lowering the temperature to you're making a new alloy. And the way to do that is we're going to actually get a can right here, and we are going to try to go around and lower the base temperature of this lid. And the purpose of that is to make things easier to get off. So let's look around here. So in order to do that, we have to get some low melt, put it on the tip of our iron, and get an iron that's small enough that it can get actually all around there. This is an example of low melt. This is another example of low melt. This stuff is called Chip Quick. It is a very low melt alloy, and it works very well. But what is the disadvantage of this? The disadvantage of this method is if you get this on other components, you're going to make them more brittle for if you're going to, this is going to be a repair, then those components could actually break off easier, and you might actually short different things that you don't notice that the low melt got underneath the chip or got somewhere that it's not supposed to be, and you have problems. So we'll get a little bit of this. I'm actually going to put some on the tip of my iron, and I'm going to go through here, and basically I'm going to use this low melt. But see how it's acting like it's not fluid or anything like that? That is because we're not using flux. So if you don't using flux, you're not actually soldering. So what we're doing is we're making a new alloy by combining this alloy with heat. I have my iron at 400, and I am making a new alloy. I'm using this alloy to make a new one. So I have to try to go everywhere I can with this out. I gotta put flux everywhere. Alright. So I'm trying to combine these alloys and making a new alloy without trying to touch the bismuth, which is the low melt, which is the 148. They also sell 138, I think, too, and even lower. I think the Chip Quick's even lower than that. But you got to remember, the lower the element that you're going to be using in here to try to downgrade this metal, then if you get it on something else, it's going to be even more brittle. So sometimes you can't get to certain spots. Well, if I can't get to it, then I can't get to it, but at least I can have it as my starting point. It's not really wanting to go in there very much. So this is what I'm doing. I'm basically going all the way around this lid and trying and hoping that this stuff is actually getting in there and forming that new alloy. To be able to remove this lid. And I shouldn't have put it on this lid right here. That's the mistake. Don't do that. Alright. And then the theory is that now in between that's holding this on is going to be even lighter. Now that's going to be a different alloy that's holding that on. So I get my trusty little tweezers. I'm actually going to use these. These are ones that I got from the Practical Board Repair School. I know they're pretty tough, so let's use these. I like these because they have a very, very small type of head right here. And this is what I'm going to use to hold it and hold it up while I apply max heat and max nozzle strength with max air. Okay. Now, if I look around here, there is a ton of different components that are around here. So the best strategy that I'm going to use here is I'm going to try to blow it on this way, so these components over here are not getting the brunt of the heat. It's actually going out this way. And so I'm going to try to hold it by this right here, and hopefully that, with the weight of the actual thing, will be enough. Now, another thing you got to think about is when I'm doing this way, I'm going to get the heat is going to be going towards my hand. I have to be mindful that if I hold it that way, the heat's going to be going towards my hand. So maybe I should hold it over here, and then that should do it. So we're going max temperature, max heat with a downgraded alloy. So let's do it. Oh, what did I do wrong? I didn't change out my tip. I still got that big tip on there. And actually, I'm going to go to, I'm not going to use, I'm scared I'm going to bend those tweezers. So I'm going to go to my go-to tweezers. So I know these guys aren't going to get bent. And this should work by holding it like this. Okay. So I got to take these off. Are they hot? Yeah, that's pretty hot. So that's why they make things like this, to grab it and take it off. Alright, now I'm going to go in max heat, max temp, use gravity to use gravity. Gravity is going to actually pull this thing off. I want to get as close as possible without touching the PCB. It's cooking my fingers. Alright, let's see if I can cause any damage. So the good thing is around this, there is not that many components. Now, the actual low melt, did it actually get around here? I don't know. So a lot of this is trial and error. This chip right here, we're going to look at it. Now, does this chip have underfill? Well, if you look at this chip, go around it. Oh, that bitch is hot. Does it have underfill? Can you see the traces? Can you see the traces going around the board? Well, I can see traces right here. So this chip has no underfill. So these chips are easier to remove. Another thing that you have to be mindful is when you're taking these off and you're going into the ZXW, you have to watch out for crystals. Crystals are different things that you're going to find. I don't know if this is one right here. But a crystal is basically the guy that keeps the drum beat. How does phones communicate? Well, phones communicate with between each other with data lines. So if the data line, one of the chips is saying 1100, and then the other chip says, did you say 1101? And how to eliminate that is that we have these crystals in our phones, and basically they're a substance that oscillates, vibrates, and that frequency keeps the chips from constantly talking at the same time. So it would be 110001, and then that's how the chips know how to not to talk over each other, because they're always following the drum. And that's how people actually overclock their computers, by actually making the frequency of the crystal faster. So in recap, what are the three ways? Earlier iPhones, max heat, max air, biggest nozzle. Later in the iPhones, pry and pray works well. The drilling method and cutting the actual PCB off is not recommended. And then the final way is to downgrade the alloy that's holding the lid on. You got to take your time and get around there as much as you can to be able to pry the lid off eventually if you can't get to all of it. And just remember, when you are using the pry method, that you're watching out for canning around the chip. Lastly, be mindful to support the actual motherboard so it does not bend and you actually crack other vital connections that run through the motherboard. And these traces that you don't see. Remember that if the shield is soft enough not to cut too deep into it while you're actually perforating it, and then you're able to pry it off. And then lastly, the downgrade of the alloy around the chip to be able to get it off. Use ZXW whenever you can, and then that way, if you're actually taking a component off, so say we were taking off this can right here, okay? If we were taking off that can, then we would go, since we know we have this phone in our ZXW, if we would go here, we would actually be able to see underneath of it and see how would we tackle this and going in there. If we started perforating it, where would we actually get canning? You're going to be getting canning right here probably and right here. So I think our best plan of attack here would be actually to try to cut over here maybe and perforate as much here, because you got a lot of space here. So this is how you would know how to approach this. If you knock the capacitor off, would it be okay? It'd probably be okay. Capacitors, they usually have multiple capacitors that are doing the same thing. What a capacitor is doing is it's basically evening out the power. So you're most likely to be okay by doing that. But that will give you an idea. And we're not going to be going in here unless it's 100% necessary that there is a chip that we're actually need to get in here that we're working on, and that we have to have that. See, on this chip, there's no information. I don't have barely any information on what this chip is doing, but I do see that it's tied in to the PMU over here. See, that's a chip that's surrounded by a whole bunch of coils, and that is the telltale sign that this is the power management chip. All right, so a lot of those channels go into here, so this is probably a very important chip. And if you knock this capacitor off, well, you got other capacitors near it that will probably be okay. So that's how you know. I hope you guys learned something today, and that was the first half of what we learned on the second day of Practical Board Repair School. I am still trying to get better at these videos. It's hard to edit. It's hard to get everything right and to do all this. It's not easy, but I am doing the best I can. I'm getting better at it. Please ask any questions in the comments. I'll be happy to answer them as best I can. And you guys have a great day. This is Richard from Repair Room USA. And I will see you next video with the second lesson of Tuesday, which will be reballing a larger chip, taking it off, reballing it, and then get some experience doing that. Thank you.